Hey everybody, this is the thing. This is one of the newest things that I think is most fascinating about my ideas. Um, it's a combination of a dimensional reduction and a holographic reduction. And these are just ideas that I'm playing around with. I don't know of any use for them. I still don't know of any use for my magic ghost number cubes. So I really don't know of any use for my ghost number, magic ghost number Polyhedra. But this is I forgot the name of this shape. It's the inverse of a cube. Um, it, uh, it has it has 8 sides and 6 vertices, corners. And this has 6 sides and 8 corners, 8 corners. And so this is the closest thing to our three-dimensional world that we have, and this is the model three-dimensional world. And so this is a whatever this polyhedra is with 8 sides labeled numbered 1, 2, 3, 4, 5, 6, 7, 8, and its inner ghost number. And this is in an addition form. Its inner ghost number is 36. To reduce this to a three-dimensional form, you have to have 6 numbers, and this has 8. So you put 2 zeros, one on both sides of one axis, any given axis. And there's only 4 axes, not axes to this object. There's this axis, that axis, that axis, and that axis. So there's 4 different combinations. This ghost number is 36, and I'm not going to go through the math, but I'll tell you that 36 is quadruple 4 times. It's quadrupled the word for 4, quadruple 4 times to end up with an outer ghost number, amplified ghost number of 144. And these numbers 1, 3, 4, 5, 6, and 7. 1, 3, 4, 5, 6, 7. 6 numbers. Its inner ghost number is 26, and its outer ghost number is 104. This inner ghost number 2, 3, 5, 7, 8, 80. 2, 3, 5, 7, 1, 2, 3, 5, 7, 8. I didn't put 1 there. Its inner ghost number is 25, and its ghost number is 100. This inner ghost number is 28, and its inner ghost number is 112. Its inner ghost number is the same thing, 28, and its outer ghost number is 112. For right now, I don't know if there's any reason for these to be the same, and whatever. But these are all the different possible combinations of putting the zeros at the axis to reduce it to a 6-number cube form. So this brings it down to our dimension, to our dimensional reality. And to double reduction, bring it down from a dimensional reduction, you get these 4 different possibilities. And this is only one possibility. This is this possibility right here, brought down here. This is a holographic reduction, and I had this thing about holographic everything. So this is a holographic reduction, because the holographic reduction, you put zeros on the axis of the 3 axis of the 6 numbers of a cube, and it brings it down to a square. I consider this the boundary, and this the bulk, the 3-dimensional bulk, and this is the 2-dimensional boundary. The square is 2-dimensional, the bulk is 3-dimensional. And so this is dimensional reduction and holographic reduction. To bring it down to I should have put, I don't know, should I put something there? I'm going to screw it up. This is the bound or boundary, and this is the bulk. Yeah. So this is the boundary of the 2-dimensional surface. This is the bulk, 3-dimensional surface. And this is again by putting 2 zeros, bring it down from a cube to a square. So you can see where 1, 4, 7, and 6 is 1, 4, 7, and 6, but there's no longer the 3 and the 5 here, and they're both zeros on this axis. So there's a dimensional reduction and a holographic reduction. And if you had 6 different sides, you'd have to go from 6 different sides that would have 3 different combinations, I think. So 8 different sides. That's 5 different axes, which would have 10 possibilities, to 4 axes, which would have 8 possibilities, down to 3 axes, which would have this possibility. We wouldn't have this possibility. It would have a holographic bulk and a holographic boundary. So this is just ideals I'm playing with right now. And the neat thing I keep on thinking, I don't know if I read this. The neat thing I keep on thinking is that on a 3-dimensional cube, all the numbers fit exactly. They fill up all 8 quadrants, octants, since we're dealing with 8 in that coordinate system, 8 octants, the outer cubicle and the inner cubicle, but the outer. I didn't fill these out, by the way, the whole cube. I just showed the primary numbers in blue, the inner central ghost number, and the outer ghost numbers. And I did fill this out, but that was easy. But this is all in addition form. So there's dimensional reduction up here. I think if you read that, dimensional reduction and holographic reduction, because it brings higher dimensional objects down into our 3-dimensional realm. And then our 3-dimensional realm is split up between the bulk, the 3 dimensions, zeros in this place, and the boundary. And the 18 central ghost number of this cube, this square, is also 18 on the outside. I guess that can be some sort of identity. I'm not sure if I'm using that term correctly. But the identity of the boundary, I don't know. And the outer ghost number for 18 is 54, because I didn't add that, but it's 54 plus 54 plus 54 plus 18 plus 18 plus 18. I didn't write that in. 8 and 8 is 24. Carry the 2, and the 1 is 5, so it's 54. I didn't do that, but this is what I think is fascinating. What I really think is fascinating, is neat or whatever, is that you can't put any numbers rightfully around this higher dimensional object and still say that it fills out space truly like it should. But you can put only 8 numbers around the octants of this cube, and you can only put 4 numbers around the square. So I think that's neat that you can bring a higher dimensional object down to our 3-dimensional realm, and bring our 3-dimensional realm set there, the bulk and the boundary, and dimensional reduction and holographic reduction. So that's it. And this is something that's going to require a lot of crunching numbers, because there's 4 different possibilities, and this is just only one that I've brought down here. There's this possibility, and this possibility to be made with these holographic reductions. And I'll probably do all this on paper, and it's going to be frustrating to keep up with all the numbers and everything. But and maybe that'll offer clues to what all this stuff means. And I'm not sure if it means anything, or if it's just some sort of recreational math, like I think my magic question cubes could be, but I hope it's something more. But these are dimensional reduction and holographic reduction. I think I'll just repeat myself right now. So this is the reason I was going to have dry erase markers